All right, now for number 7, we want to know what would best represent the velocity versus time graph for the buggy. So here's the buggy graph, and notice we have a steady negative velocity. So if we were actually to plot the velocity versus time, we would actually end up getting a steady flat graph like this one here. And if we were to actually put a number here, this would be negative 25 centimeters per second. And it's choice D that's correct. Now here we have a velocity versus time graph and we want to know what the object's doing. So notice here we're going fast and forward. Here we're going fast and backwards. And here we're stopped. So what does this mean? It means initially we're moving forward, we slow down, we stop, and then we speed up going backwards. So actually it turns out choice A is the right choice. For number 9, an object is dropped from rest from a height of 15 meters. What is its approximate speed when it hits the ground? So we can use v squared is v naught squared plus 2 times the acceleration times x minus x naught. And let's plug in our numbers. I use this one because there's no time given, so we'll see if that works. So v squared, my initial speed is 0. 2, acceleration is due to gravity, so it's falling, so that's 10 times 15. And so v is going to be the square root of 300. And when I actually solve that out, it works to be about 17 meters per second. Now, a similar problem for number 10. The object is dropped from rest to the ground from a height of 15. We don't know how much time it takes to hit the ground. Well, we can now use v equals at plus v naught because I know that v final is 17, acceleration is 10, and I know that my initial speed is 0 since I drop it from rest. So that gives me a time of 1.7 seconds right here. Now here, positive means forwards, negative means backwards. An object is moving backwards with positive acceleration. What does that mean? It actually means it's slowing down. I'm going this way, so that's where I go. But acceleration wants to force me this way. And that's why it slows me down. And then for number 12, a model rocket with good propulsion can launch with an initial velocity of 40 meters per second. If we fire it with the speed, what's the maximum height it'll reach? So it reaches the speed, and then we're going to say the engines turn off then. So we don't have time, so I'm going to use the kinematics formula that doesn't have time in it. So I know that my final speed is 0. My initial speed is 40, so I square that, plus 2 times 10 times x minus unknown. And I'm just going to work with absolute values here. So I'm going to get 1600 divided by 20. And when I actually solve that, I'm going to actually get 80 meters of height is what the rocket is able to achieve. And for number 13, which statement best describes the distance traveled by both objects from t equals 0 to t equals 10? It actually turns out that the distance traveled can be calculated from the area. So here I've got 1/2 times 20 times 10, which gives me 100 meters. And then here, 10 times 10 is 100 meters. Again, I'm using the area of a triangle here, and this is the area of a rectangle. And so I'm actually getting that they travel the same distance. Now, because none of these others work out. Now, how far does the object travel? We actually calculated that just now as 100 centimeters each way. So, for each one, I mean. So that's questions 8 through 14, and in the next video, we'll take a look at the remaining multiple choice.